The title of Vladimir's talk is, Can Stroke and Alzheimer's Disease Be Prevented? I haven't looked at the abstract too closely, but even from the title, I'm intrigued with this talk. So I'm going to enjoy it, as I'm sure you will. I invite you all to stay after the seminar. We will have an informal discussion just around the corner a little bit to room DC 1316 to discuss Vladimir's research and possible collaboration. So I hope you can stay for that as well. So Dominic, will you introduce our speaker?
Welcome to all of you and to you, Vlad. It's I won't. You can read the lengthy material in the announcement. I just like to make a few personal comments. I had the privilege of meeting Vlad many times, but the most recent time was about 2 or 3 weeks ago, when we were at a large meeting in London related to the University of Western Ontario and creating a Canada Innovation Fund, CFI, Canada Foundation for Innovation research program in clinical medicine. So interestingly, that was the first time I had seen him for about 30 years. So there's a big gap there. The good news is, yeah, we're boys, real boys. He was a taller boy, though, I'll tell you that. He stands next to me. He's about 1.5 feet over my head. And it was just like old home time. Now, the interesting thing is my wife's here, Carol Thompson, and they are classmates. So we have a family connection here. We spent lunch talking about all of the people we know and knew and every little thing, and it's really quite like a homecoming kind of thing. So it was incredibly nice to meet Vlad again, and immediately he glommed onto me, as he did back in the late 1970s, and said, "We're doing interesting stuff. Do you think informatics has any role, and could we do anything with them?" And I said, "You bet." So very, very interesting. Also over at lunch, Vlad regaled us with, we won't be able to have time to do it today, with an honorary degree I'd received at the University of Salamanca in Spain. It's an incredible program. I try to get him to write it up or do it on tape so people can hear it, but he wears a beautiful button that I asked him about this degree, and only 2 are awarded each year. The good news is they've been awarded since about 1250, and very, very honorable, and probably, I'd say, one of the most global recognitions of the greatness that you've brought to this field. Through the years, we've read about your work. We've seen your publications in a number of places, and always been honored to have known you, and very much honored to not only know you again, but to have you here today. Vlad, welcome.
Do you have a pointer? Oh, okay, so that's it. Well, thank you, Dominic, for a very generous introduction. I share the same feelings as you. It's friendship, it's reconnecting, it's wonderful. And I do hope that we have enough in common to begin collaborating. That's my earnest hope. I very much look forward to having come here. And the best part, I think, is going to be afterwards when we talk about the possible implications. Now, it turns out that, at least in the Western world, 1 in 3 of us will end up with a stroke, demented, or both, unless we do something about it. It's become that bad. And it turns out that we know the statistics for the developed countries, specifically the Framingham study in New England, but we know that this is not limited to the developed countries. In fact, it's a global problem, and I'll share some of the information with you. And so I'm going to divide my talk into 3: the growing menace, Alzheimer's disease and stroke; second, the limitations of current approaches; and then finally, suggest that the time has come to have some sort of common approach and do better than we have done. At the present rate, we will not stem the tide, and that has tremendous implications, both personally and socially. Now, this graph illustrates 2 points. One is the growth of the world population. And I want you to note that the cities, these are cities that have 10 million or more inhabitants, and the distribution is interesting. 5% of the world lives in North America, 9% in Latin America, 12% in Europe, 13% in Africa, and 61% in Asia. So it gives you some idea of where the numbers are. So most strokes occur in developing countries. Most Alzheimer's disease occurs in developing countries. Now, the second point that this slide illustrates is the phenomenon of urbanization. In 1900, 15% of the world lived in cities. As of this year, 2006, half of the world lives in cities. And often there are these mega cities that have some rather important implications. Increased caloric intake and decreased physical activity. And this caloric intake has a differential effect. In other words, people of Asian origin, East Asian to be specific, and also some of the native populations of the Americas are particularly prone to diabetes. For the same weight, someone from say, China or a native, an aborigine from Canada or elsewhere in the Americas will have 60% a greater chance of developing diabetes, which carries risk for Alzheimer's disease, carries risk for heart disease, carries risk also for blindness, and also stroke. Now, one of the consequences of this increased caloric intake in the big cities is also a decrease in physical activity. And this is from the New York Times telling you that these little children, I mean, the only exercise they get is what's stated here, 50 minutes a week. Whereas, you know, say rural children, I mean, they'll be running all the time, walking to school. And this is a phenomenon not limited to children. It's a universal problem. And this is actually, we're doing a project in Manitoba, and this is a First Nations individual. We're doing the first study of a native population at risk for Alzheimer's disease and stroke. And we're using a technology developed at the Robarts Institute in London, which is three-dimensional ultrasonography, and then combining it with cognitive testing and with taking photographs of the retina and sort of a sophisticated inventory of the risk factors. Now, the increase in caloric intake has been coupled with a decrease in physical activity. And a colleague from the University of Toronto and I have estimated that physical inactivity is the single largest contributing factor to stroke in Canada. Now, physical inactivity by itself is not a powerful predictor of stroke. High blood pressure is. Yeah, oh, I didn't quite. Oh, this works. Thank you. This works. Hypertension, but since physical inactivity is more prevalent, it accounts for a larger proportion of strokes than hypertension alone. And please appreciate that these are related. In other words, physically inactive people are also people who tend to be overweight and therefore more likely to have hypertension. They're more likely to have diabetes. They're more likely to have what's called a metabolic syndrome, which is a combination of all the above. Now, the same applies, interestingly enough, to the likelihood that someone will develop cognitive impairment. And this is from a Finnish study that shows you that the individuals who are physically active are less likely to develop impairment of their mental abilities than those who are physically inactive. And I think that the impact of that is fairly high. In other words, it basically, people who are physically active can reduce their risk of developing difficulties with their thinking by about half or down to almost a third, by 2/3 in other words. Now, the Queen has known for a long time that the population of Britain is aging, just from the number of birthday greetings she has to send to centenarians. However, this is not limited to Britain or to developing countries. And I think most of us by now know that the world population is aging, both in absolute numbers and relatively. What most people don't appreciate is that the children over the age of 5 are not increasing in proportion. So we'll have a higher proportion of the very elderly people and the same number of young people, which also creates all sorts of economic and social problems. Now, stroke can occur at any age, even before birth. You know, cerebral palsy is, many of those cases are actually in utero stroke. But it remains true that after the age of 65, there's a fairly sharp increase in the incidence of stroke. If you look at the incidence of Alzheimer's disease, then it's similar. After the age of 65, it goes up pretty steeply. And yet, these conditions are looked in isolation. I mean, that's one of the difficulties, that we're not looking at them together. And this brings me to the limitations of current approaches. Now, typically, we deal with the extremes of this condition. Either you have a clinical stroke, you come to hospital, and the stroke doctors look after you. And by and large, stroke doctors are not interested in cognition. You know, if you can move, that's all right. I mean, people will not ask you about what your intellect is. And then on the other extreme, the people interested in Alzheimer's disease, well, they're not very knowledgeable about stroke or prevention. They don't even know about risk factors. So it's, you know, they're going divergently. And here's an example of why the stroke, this is one of the widely used scales, the National Institute of Health scales, and it gives you 21 points out of 40 for motor activity. In other words, you ask the patient, move your arm. Now, that's more than half of your brain's function, but that's not true. You sitting there are using more of your brain than somebody lifting his arm. And the reason is you have to be alert, as far as I can tell, so that takes a certain part of the brain. Then you're listening to me. That's another part of the brain, actually getting the sounds processed. Secondly, you're interpreting what I'm saying to you. Fourthly, you're making some sort of judgment. What is he talking about? And you're probably getting some sort of emotion. Oh, not this afternoon. I gave up a sunny day to listen to this guy. You know, look how many parts of the brain are involved. And yet we don't tap that. You know, we say, okay, if you can move the arm, you're fine. I mean, that's just not right, you know. It seems so obvious when you talk to a lay audience, but, you know, this is what happens every day in hospitals. We are too busy to look at subtleties. Now, this is perhaps one of the most important slides I'm going to show you, and it's available in the literature, but it's not something that has been given enough publicity. The Framingham study is something that's been going on for at least 3 decades, and it has really given us the information that has identified which are the risk factors for stroke. It turns out that they have created an index. They call it the Framingham Risk Profile, which is the likelihood of developing a stroke in the next 10 years. And as you can see, these are things you're familiar with. You know, the older you are, the more likely it is. The higher your blood pressure is. If you're on hypertensive medication, if you have diabetes, if you smoke cigarettes, if you have heart disease in the family, if you have atrial fibrillation, which is an irregularity of the heart, and then if you have enlargement of the heart. But what these investigators did, they took that index and they took people living in the community. These are not patients. These are people who live in Framingham, Massachusetts. And they did some mental testing, very extensive testing of different brain functions. And they found a very high correlation between, inverse correlation that is, the higher the stroke index, the less their cognitive function. And these tests largely reflect what's called executive function. Executive function is planning, creative thinking, mood, not memory.
Could the causality go the other way around?
How's that?
Could the causality go the other way around?
I'm not sure.
Being intelligent reduces your risk.
Can you just, we record this, so could you hold your question so now if you want to ask a quick question?
I was only... You were implying that the risk factors hurt the intelligence. But could it be the case that the causality goes the other way around? The more intelligent you are, the less likely you are to suffer from dementia or stroke or whatever? I mean,
it's a good question. What I'm showing you are correlations. I'm not showing you causality. Yeah, that's correct. I would take your point. And that will become relevant when I'm talking about prevention of dementia. It's a valid point. At the moment, though, I'm talking about correlation and its direction. And I wanted you to note that the correlation of vascular risk factors is with executive function, not memory. And that'll become relevant in a moment, because all our building blocks for identifying people with trouble with their thinking is memory. And that's inappropriate for difficulties thinking on a vascular basis. Now, this is actually on Sherlock Holmes, and he complained that among detectives, you know, his colleagues tended to jump to conclusions. I confess, neurologists have the same problem. Now, let me begin by criticizing our common approach. Now, I just mentioned to you that memory is not something that's impaired in the presence of vascular risk factors. And yet, our definition of dementia is that you have to have memory impairment plus an impairment in some other domain, like executive function. So that is obviously inappropriate if you deal with cerebrovascular disease. The second thing that's wrong is that by the time you're demented, which means that you have such impairment you cannot look after yourself, it's too late. And with vascular disease, often the trouble is not progressive necessarily, and it's not that severe. You know, people may have some difficulty thinking, they're not as creative, etc., but they don't have the fatal disease called Alzheimer's, which typically they die 8 years after it was diagnosed. And last, the most important, the criteria we use do not work. And I'll explain. There was a Canadian study for health and aging which studied over 1,000 subjects over about 10 years. And one of my former fellows, who's back in Finland now, University, looked at 1,879 individuals who by consensus were considered demented. In other words, their mental impairment was so great they couldn't look after themselves. And then he applied some of the commonly used criteria for dementia. And depending whether he used DSM-3, 29% of Canadians over the age of 65 are demented. If you use the more strict one, ICD-10, then 3% are. Now, would you use a laboratory test that could give a result that would vary by tenfold? I mean, come on. I mean, this is not real. If you were Minister of Health of Ontario and you had an expert say, well, you know, Mr. Smitherman, you know, we could have as little as 3% of the population demented or 29%. Well, a huge difference. Do we build nursing home? I mean, what do you do? I mean, it's just not good enough. And yet, we persist. It's incredible. I mean, I know I'm almost embarrassed to tell you, but that's the reality. I mean, it's been a struggle. The other difficulty is that because different investigators use different criteria, they're mutually unintelligible. You know, there's a tremendous need for a semantic web here, to use. I learned that from him. All right? That if you use one criteria, you don't really know what they're talking about. You have no idea what they're describing. And those criteria, the overlap is minimal. We also have done those studies too. You would have thought that there would be a core that everyone identifies and the more liberal criteria identify the others. But it's not so. There's a little overlap among them. So there is a Tower of Babel, and we cannot build on each other's knowledge because we simply cannot compare the studies. So we have isolated observations that are interesting in themselves, but we cannot have the power of synergy, of getting that information and applying it to the problem. And I believe that acknowledged ignorance is a form of knowledge. That we have to begin by saying, this doesn't work, we can do better. And we can. I mean, that's why I'm here advocating it, because I think it's possible. Now, this is what I said to you earlier about the combined risk. This I said at the very beginning. This is just the data to support it, and that is the combined risk of having stroke or dementia is really 1 in 3, which is really very high. I mean, if we live long enough, then we'll suffer one of these brain diseases, which has all sorts of implications. Now, this is a slide based on the Canadian Study for Health and Aging. It's been accepted for publication and yet unpublished, and the first author, Dr. Jin, who's in the audience. And this, again, this has not been published, but I think that once it's published, I think this will become a bit of a classic graph. Why do I say that? Because it's so absolutely brilliant. Well, Dr. Jin is brilliant, but that's not the reason. This is the first hardcore, well-based evidence that for each patient who has a stroke or is demented, there are 2 who have some cognitive impairment short of dementia. And this is the large silent minority. Let me explain. 8% of Canadians over the age of 65 have a stroke, 8% are demented. But you see, all these people, they're not in hospitals. They don't even come to the doctor. If they complain to the doctor saying, you know, I used to be so creative, you're able to answer those puzzles, I can't anymore. And they say, well, what do you expect? You're 73, right? So, and these are the very people that we can probably do the most for, at least in principle, because many of them have the risk factors that we know can prevent stroke, and that has been proven. Then the next big challenge is, on the basis of this association, if we treat those risk factors, can we prevent and delay Alzheimer's disease? Now, that remains a question for the reason that your colleague said. At the moment, it's a strong association. There's some tentative studies to show that decreasing blood pressure, for example, decreases Alzheimer's disease. But that's the beginning. So I think we're at the beginning of cause and effect, but we're not there yet. Now, the other factor that we have come to realize, thanks to MRI, is that for each stroke we know about, there are about 10 that we don't know about. They're called silent. They're typically small. They typically don't affect the body. They affect the mind and mood. And late life depression is associated in some cases with these small little infarcts and also with white matter changes. In fact, it's exceptional. After the age of 60, it's exceptional, if you live to be 85, not to have one or more of these. And here's, again, there's so many things that are important in retrospect which are disregarded at the time. This, again, is an article that most people wouldn't jump to because it was published in, this is not a very high impact journal, you know. And so people say, well, it's not in the English Journal of Medicine, then why would you read it? Well, you know, not everything in the English Journal of Medicine is good. Just on average, they have an impact. But again, it's a few articles that account for the impact, not the majority. But anyway, I believe this to be an important article. And the reason I say that is that this is a first population-based estimate of the true incidence of the different types of strokes. And in the United States, in 1998, there were 770,000 strokes. It is estimated that there were about 10 million silent strokes, so-called. Now, if you did testing of cognitive competence, you would find that they did have some impairment, just it wouldn't be severe. And about 2 million silent hemorrhages, usually small little bleeds. And we're just beginning to discover the significance of these. And there's another phenomenon called leukorrhiosis, which is just white matter change, which is associated with decreased reaction time and also some cognitive impairment. Now, these are some examples of those microhemorrhages I told you about. And these each is a different medical condition, but look how peppered they are with these little holes. And they cannot be good for the brain because if you spill blood, you get a reaction. The brain does not like iron, and you create reactive radicals that then cause damage and inflammation and so on. So probably this is not good for the brain. Now, the other sort of concept I wanted to share with you is that I believe it is probable that in individuals who have the right genes and predisposition to Alzheimer's disease, that stroke can precipitate Alzheimer's disease. Why do I say that? Because if you look at series from different countries, from France to China, about 20% of stroke patients admitted to hospital, if you examine them at 3 months, they will have significant impairment of their ability to think. And it's not limited to the damage caused by that particular stroke, which is often limited to a particular part of the brain. It will be a global impairment, and typically it's progressive. In 2/3 of cases, it goes on to become worse and worse and worse. And for all we can tell, they look like they have Alzheimer's disease. So the question arises, can stroke precipitate Alzheimer's disease in the individuals who are already prone to developing it? Will you precipitate it as opposed to developing at a later stage? Now, the other thing that I'm going to tell you, it sounds as though I'm a big radical telling you that most of the things that you have heard are incorrect. Well, I'll tell you one that is incorrect. Let me begin by asking you, again, I don't expect you to have the statistics, but what do you think the commonest cause of mental impairment is? Alzheimer's disease? How many people would say yes? Well, if you read the literature, if you read the papers, you would have thought that, if you have some trouble with your mind, it's Alzheimer's disease. But the difficulty is that most of those reports come from Alzheimer's centers. Who goes to Alzheimer's centers? People with memory problems. What are they likely to have? They're likely to have Alzheimer's disease. So no wonder. I mean, it's called ascertainment bias. If, on the other hand, you look at a population, this happens to be in Oxford, England, and you look at the people dying with cognitive impairment, it looks as if the type of vascular lesions and little strokes, changes in the blood vessel, are just as common as Alzheimer's changes. So the commonest type of impairment is really a combination of the two. And if I'm right that little strokes can precipitate Alzheimer's disease, then it means that we potentially could have prevented or delay it. Now, let me now come to the third part, which is, okay, it's always easy to criticize than to offer something instead. Well, I think that we have to develop a common vocabulary for the reason that I told you. Those criteria that were being used are not worked. And I'm happy to report that last year in Washington, we held a workshop in which we had experts in epidemiology, clinicians, imagers, pathologists, experimentalists, and we asked them to please develop standard minimum criteria for clinicians to use, people who look after patients in their offices. and also for researchers to use. So that regardless of what criteria you decide to use, we have the elements, and we can break down what it is that your patients have in terms of description. Again, taking the vocabulary you taught me, this sounds like the first dictionary of a semantic web in the whole field of stroke and Sylvester disease. And this is coming out in the journal Stroke. And I think it'll be a landmark paper because, in fact, it will be the first time that, if 1 in 3 people are going to develop stroke or Alzheimer's disease, and this is the first guidelines to having a common language, potentially this is very important. Now, I'm standing by for big cannon sort of saying, well, there goes Hachinski again, and people don't want to give up their concepts. I mean, you have vested interest. If you spend your career saying that a change in amyloid, which is one of the proteins that misfolds in the brain, is the cause of Alzheimer's disease, and somebody tells you that maybe stroke precipitates it, we are going to be happy. You're not going to reverse gears if you become famous for it. The same goes for each little compartment. But I think that the common sense of it will prevail. But I think we need better ways than having amateur databases run by physicians, even with their expert help. And that's why I'm here, because I think we can do better. And this is just to tell you the expert groups that develop these mineral criteria. And that's just the indicator that's coming out in stroke. Now, what I'm advocating is what I'm calling an idea center. And that stands for idea and, let's see now, I've forgotten what it stands for. Idea and data exchange acceleration. In other words, I'll give you an example. If the standards that I talked about are adopted and then you make the databases compatible, you could generate a hypothesis in one database and answer already in the other because there are a number of longitudinal studies that actually have DNA as well. And you can re-examine the same database and you can do extra examination of the DNA without starting a new study. I mean, the wealth of that is tremendous. Now, one has to start modestly because you can imagine that everybody has vested interest in their own databases, so we have to start slowly. But I see tremendous potential in that. That's just epidemiology. It turns out that the epidemiologists don't talk to experimentalists. I mean, when we got those people together in Washington, it was sort of the first time you had experimentalists in the same room as epidemiologists. They would never meet otherwise. And we had a follow-up workshop, by the way, last weekend on the experimental side. So, I mean, this is we got something started. But anyway, the idea will be the following, that you generate some questions. For example, one of the things I found out, I told you earlier, I haven't told you, but you ought to know that drinking wine in your 50s will make it less likely that you will develop cognitive impairment at 70. Except if you're ApoE4, which is one of the variants of one of the proteins that carries fats, in which case it's bad for you. Now, the good news is that if you actually don't drink, etc., and do the right things, then the impact of that behavior is greater than if you did not have that particular gene. But what occurs to me is that you see, if some of the experimentalists knew, there are all sorts of models of alcohol in the brain. Why not take that observation, work out the biology and experimental group, and then go and see what happens with people again? You can make that back and forth and back and forth and back and forth and really accelerate knowledge. Similarly, we have results from clinical studies. Again, they're totally in a different world. I mean, they may be studying the same problem, but I mean, they never enter a database. I mean, it's one to integrate the knowledge. We also have administrative databases. In Ontario, we're quite lucky. We have very good monitoring, not only of what patients are admitted, what they have, but what medication they're on. Again, if you could tap that by some sort of the modern things that you're developing and begin looking at questions, a lot of the answers are there already. They just need, they talk about translational research. You cannot have translation without translators. And at the moment, we advocate it, but there's no infrastructure to make this come about. And in fact, there are many disincentives. Everybody is so busy doing their own thing. Why would they venture own their field and get slaughtered? They put an application in and they say, well, why are you venturing outside of that? What do you know? You have no track record. So it's a real challenge. And this is to tell you again that to reemphasize the point that there is a strong association between the vascular risk factors. Again, this happens to be age 50 and age 70, and the likelihood of developing cognitive impairment. It's a strong association. And I won't be spending a lot of time telling you about some of the studies that show that controlling high blood pressure and cholesterol make an impact on cognition. But I think the more important point is that in principle, we should be able to make a difference, and we need more studies to do that. Now, a recurrent theme from my presentation here is that knowledge is acquired in pieces but understood in patterns. And yet, we give all the kudos to the ones who give us the little pieces, not the integrators. Right? I mean, if you're too theoretical, no data. But then, I remind you that the most influential biological paper in the 20th century was the one by Crick and Watson, in which described the structure of the helix. They had no original data in it. It was less than a page. Okay, so you can take, and in fact, I'm going to start a prize for the journal Stroke, which I edit, and I'm going to call it Double Helix Prize. And the theme is going to be to see what everybody else has seen and to think what no one has thought. Because I think we need more ideas, creative ideas, to actually test. We still have to have the proof. I don't believe in these theoretical constructs cannot be tested. But I think we need more people to integrate and to think beyond what we know. The other important point, I think, has to do with focusing on mechanism and seeking common therapeutic targets. Now, it turns out, I often show this to medical students, and I have a little quiz for them, and I said, inflammation, apoptosis, mitochondrial DNA impairment. What's the disease? Alzheimer's disease. I said, right. I give the same list. MS, right. Stroke, right. Parkinson's, right. It turns out that the brain functions with amazing complexity, but it fails in a few predictable ways according to these basic mechanisms. There are hundreds of symposia and lectures and congresses on Parkinson's disease and Alzheimer's disease. To the best of my knowledge, there never has been a single symposium looking at these basic mechanisms from the viewpoint of what has been learned in those different ones. And here again comes in, if you had a system, and here I'm appealing to you, I'm using some of these keywords saying where you can help us, of actually bringing that knowledge together, we already could be advancing. I'll give you a specific example. Some years ago, there was someone working for Upjohn Company, a pharmaceutical company, to develop something that would treat Alzheimer's disease. You know, one of the drugs that was one of the primitive forms of the drug that is widely used now to treat cholinesterase inhibitors. It turns out it was not very good, and the company didn't pursue it. But it had a very interesting side effect. It produced hypothermia, decrease in temperature. That turns out to be the most effective way to protect the brain. But no one has tested it because it's out of patent. But if we only knew that at the time, couldn't we be doing it? So again, I'm sort of pointing out opportunities for integrating things. Now, the other point also is that, again, this same integration there has to be some sort of mechanism to bring this to attention. For example, this is from a famous nun study in which they looked at the brains of nuns, and they looked at their brains, and 57% of the ones that had Alzheimer's pathologically had some trouble in life. The rest didn't. If in addition they had a stroke in the cortex, the rind, then 75% of them did. And if they had a small stroke at the core of the brain, then 93% of them did. It didn't make any sense that a small lesion would produce such a global effect. Now, as it happens, epidemiologists don't talk to experimentalists. But as it happens, I have a colleague who's an experimentalist. So I said, well, why don't we devise a model where we can actually try to see what happens, at least in the rats, because these are the small little strokes I'm talking about that will make it more likely that people who have trouble with Alzheimer's changes. And so that we actually patented a model, and the model consists of having a rat find a hole, and it turns out that they don't like noise or light, so they try to find a hole. And then what it shows you, again, you don't have to understand the specifics of the data, but the point is that they learn fairly quick, and they remember even weeks later. If you produce a little stroke in the core of the brain, it doesn't change their learning or their memory very much. If, on the other hand, you render them Alzheimer-like by injecting A-beta, which is the part that's toxic, that is supposed to be important in Alzheimer's disease, they have difficulty learning and remembering. If you combine the two, a little stroke and the Alzheimer changes, They're much worse at learning and hopeless at remembering, and it gets worse with time, just like the patients. So here's an example where I did the modeling myself. In other words, I read that literature. I happen to be one of those people who reads a lot. Well, okay, I brought it to my attention. But what if there were a system whereby things you're interested in whatever the area is, brings it to your attention for your consideration? I mean, you could really accelerate knowledge. And the fascinating thing is that there were major changes, mainly of inflammation and beta deposit. Beta is this toxic deposit, mainly in the hippocampus, and mainly in two areas of the hippocampus called the CA1 area and the dentate gyres, exactly the parts that have to do with learning. So go figure. A single lesion in one part of the brain causes changes at the core of the brain that has to do with memory. Now, we don't know the mechanism, but isn't that interesting? Right? And then finally, a consequence of looking at mechanism is that you can find a drug that it works on a mechanism that could actually be helpful in several of those diseases, because you interfere with some fatal path, and then you'll be able to help, say, Parkinson's disease and Alzheimer's disease and stroke. So it isn't just a disease, you're hitting a mechanism. But then the final thing is sort of what do we do in practice? Because we already know a lot, certainly for stroke prevention. What is to be done is well established. But the sad reality is that we tend to spend most of our dollars in acute care and chronic care, but not in prevention. This is typical of developing countries, that Canada, which is in this group, spends only about 3.5% of the budget on health on prevention. And in the United States, and probably also in Canada, the money that is spent is not spent wisely. Some years ago, there were 5 diabetes clinics established in New York. All but one have closed. Why? Because of this. If they got a nutritionist to advise a diabetic what to do, it cost $70. They only got reimbursed $15 or $20. In other words, they were losing money. On the other hand, if they did bariatric surgery, clamp part of the stomach, which took 40 minutes, they got $50,000. Now, if you're an administrator of a clinic, I mean, guess what you're going to do? All right? Again, I'm not trying to pick on the Americans. I happen to see that in the New York Times. The same is probably true for us, that we don't spend the money best. So what can we do? What's the future? Well, I think that we have to take greater responsibility because, we're not exactly conscious of the fact that we should be changing our environment to make it easier for people to exercise, even to walk or to be physically active. I think we'll also have to involve more individuals, and that is that it isn't just a medical problem, because it's a problem for all of us. I'm going to skip that part. And I just want to leave you with a final thought to go back to my question. I said, can stroke and Alzheimer's disease be prevented? I think the answer, on the evidence as of today, I could say with confidence that 2/3 of strokes are preventable. There are hard data for that. The question, can Alzheimer's disease be prevented, is unknown. There are a number of indicators to suggest that if I'm correct, that Alzheimer's disease is something that happens to a lot of people, but that stroke can be a trigger, then the answer is that at least in principle, a number of those cases can be prevented or at least delayed. And this is a particularly important slide because it shows you that if you could delay the onset of Alzheimer's disease by 5 years, you cut in half the prevalence. It's a bit hard to grasp, but it basically means that we all will die. And what you're trying to achieve is a compression of morbidity. In other words, we'll always die, and just like an old car, so let it be run as well as it can, and then everything goes wrong, and then, let it just go, okay? So by even delaying it, and I think because the risk factors are the same, because there's some suggestive evidence that stroke can precipitate, I think realistically the answer to my question would be Alzheimer's disease may or may not be preventable. Almost certainly it can be delayed. Thank you.
Very, very interesting. Give people a chance to ask questions. What I ask you to do is to get the microphone for me and be a patient until I get it to you. But I'll open to questions. I also want to mention that Ka-Ping is here and has agreed that she is a rare inclusion of a neurologist and an epidemiologist. So I guess let me ask you, would you like to make a few comments before, okay. Questions or comments from anyone? Don? Don?
How does Parkinson's fit into this? Because I've noticed decreased mental function with people who have Parkinson's.
That's correct. Well, the mechanism, as far as I know, is different. And that is that they get, well, first of all, neurotransmission depletion. Dopamine is the main one, but the other things that go wrong. They lose cells not only in the substantia nigra, which is the part that is very important in movement, but they also lose it in the parts that have to do with the cholinergic system, which is the one that has to do with memory. So about at least a third of individuals have a definite impairment. And most of them slow down. Certainly their processing is down. It's not vascular, to the best of my knowledge. It's not vessels.
Vlad, are you postulating in some way that stroke produces a chemical cause for the dementia, or are you making that jump?
The mechanism, we're uncertain. One possible mechanism, well, first of all, I think that vascular risk factors probably act on the brain through different mechanisms. One of them is to produce these little strokes. These little strokes will set up inflammation. And one of the cells in the brain is called microglia, and they normally will, they're garbage collectors. But once you activate them, and you don't have a mechanism to stop them, they probably go on snapping stuff, and they probably cause more damage. So you have multiple damage from little microhemorrhages and microinfarcts. Then the second thing is that also with high blood pressure, you can have some of the protein, which normally never penetrates the brain because it's very well protected by lining. This sets up inflammatory reaction, and then it peels the lining, the sheaths of the nerves in the brain, and that of course slows down the thinking process. So there are probably sort of multiple injuries. On the other side is the repair mechanism. People think that ApoE4 is very important in repairing the brain because the brain is being repaired all the time. In other words, amazingly, this interaction, your brain has been changed because of me, and my brain has been changed because of you. There literally are the protein synthesis, and there's a continuous repair. And it's thought that ApoE4 is the least effective in repair. So if you have the damage of ApoE4, you cannot repair as well. And therefore, whatever process is going to happen, it gets accelerated. But I think we're at the beginning of this because people haven't looked at the interaction. I think our group may be one of the very few in the world that are actually systematically looking at this. And we're a small operation, like we're, there's a handful of people interested.
There is some sort of other demonstration of like the autoimmune diseases,
yes,
where once something is triggered in the body, it turns on itself. And you sound like you're speaking in the same...
I am speaking in the same vein conceptually, although I'm less precise. I mean, I don't know what but it's the same idea. That's exactly right. For example, in the eye, most of the things that go wrong in the developing eye, like in babies and so on, what makes them then blind and impaired is actually unsuccessful repair. It's the repair process that actually causes the impairment, which is sort of ironic. But yes, it's the same idea without the precision of the immune diseases, which have been studied for much longer.
Can I ask a question, sort of following what she just asked you? You seem to mention the Alzheimer's or dementia type of disease probably is very different from stroke in terms of the mechanism why they are, they are so. So why you relate them all together? And I'm just a bit confused why you always relate the stroke and Alzheimer's.
Alzheimer's disease? Okay.
Yeah.
Well, the first thing is that they occur together, very commonly. I think that's an established fact. So they occur together. So the question is it just coincidence? Are they just, one has nothing to do with the other? That's one possibility. I think they have something to do with each other, and I say it for two reasons. The first one is that the lesions in the brain do not add up, they multiply. In other words, if you have one lesion in this and have another one, the damage together is more than if you had just the two lesions add up. That's one phenomenon. The other one is, I think I showed you some suggestive evidence that a number of stroke patients go on to develop what appears to be Alzheimer's disease. And I also show you our experiments in which it looks as if a stroke will change, produce inflammation and produce deposition of amyloid, which is the bad thing that acts in Alzheimer's disease. So I believe that they're related, at least in the subset of individuals who are prone to Alzheimer's disease. That's why I talk about, they're not the same diseases. No, I'm not trying to say that. I'm simply saying they occur together and they probably work together, and therefore we should have a common approach. And the thing that's immediately open to us is the treatment of risk factors, which appear to be risk factors for both.
One of the big risk factors for Alzheimer's is heredity.
Mm-hmm.
So does stroke tie in there as well, or?
You mean
it's
is stroke inherited?
I guess, or if you have a tendency for Alzheimer's, do you also have a tendency for stroke?
Oh, that's a very good question. There's a lot of processing there for all the data. I'll answer you eventually, but I'll give you the things that yeah, go ahead.
Okay. The reason I'm asking that is as you were talking, I was thinking the things that you're talking about are good if your Alzheimer's is caused by or related to stroke, but does it actually tie to heredity related? And maybe it does, maybe it doesn't.
Yes, well, let me explain. There are some facts you know about that. First of all, the heredity of Alzheimer's disease is highly exaggerated. There is a subtype that occurs under the age of 45 called which is inherited, and is inherited from one generation to the other. That's the exception. That's only 1% of all Alzheimer's disease. Thereafter, the Alzheimer lesion in quotation marks are very common, and they increase with age. Many people die with their brains full of these lesions, and nothing happens, like the 43% of nuns, for example. So to answer your question, now in terms of heredity of the other type, are you likely to have the diagnosis of Alzheimer's disease if someone in your family has it? Well, that depends a little bit. I'll give you an example. If you have an identical twin, the chances of developing Alzheimer's disease are less than 50-50. So even having the same genes doesn't guarantee you'll have Alzheimer's disease. So by the time you have it as a first parent and then a grandparent, etc., you're really diluting that. And so there is an hereditary factor, but it's not very strong for the sporadic type, as we call it. For the inherited type, under the age of 45, yes, it's very strong. But thereafter, it's there, but it's not very strong. The same goes for stroke. There's certain things for stroke. Clearly, if there's family history of stroke, it's more likely to have it. But again, it's not a high-impact thing. And many of the things are shared because the risk factors are shared. A lot of hypertension is shared. Diabetes propensity is shared. Again, environment has much to do as anything else. And again, I want to sort of give you another sort of concept, and that is that people say, well, how much is genes and how much environment? It's always both. I'll give an example. I showed you a native population. There was a man lying who was having his thing done. Now, one of my colleagues called Hegele has identified what he calls a thrifty gene. When these native populations were hunting, and the hunters that could go on use their fuel effectively, in other words, they could live on a small amount of food, had a great advantage. And in fact, by survival, many of them have that thrifty gene. Now that they don't hunt, they're sedentary and they eat all the Western foods and have this obesity. Tremendous problem in diabetes and tremendous problem in atherosclerosis. So, is it because of heredity? Yes, but it's the other way around, right? In other words, it's always modulated by the environment. So I wouldn't worry too much about if it is. I think if this is so prevalent, if most families, I mean, I think it'd be strange if you know your family history and somebody hasn't had what appears to be Alzheimer's disease, because I would claim that there are probably combinations, that pure Alzheimer's disease is rare after the age of 45. Then it would not be surprising to have a family history. But family history is not destiny. And we can do a lot by controlling risk factors, and also we'll know much more, particularly if you guys can help us to get at these data, because the answer, a lot of the answers are there.
So I'm a computer scientist, and for the purpose of this meeting,
There's water, sir. Yes, you're a computer scientist.
Yeah, for the purpose of this meeting, let's call it information science. And the question is there any infrastructure for collaboration, because you cannot extract valuable information without the expert knowledge.
Yes.
But it's very difficult to find the opportunities for collaborations between clinicians and physicians and epidemiologists and people who come from information sciences.
Yes.
And are you in the process of trying to create such opportunities? Or
Yes, definitely. That's why I'm here. And I'll be very specific. We have been part of a Canadian Study of Health and Aging, which I shared some information on. We have access to that data. Before we actually give it to a computer scientist to play around with, we have to get permission. But Dr. Jin has come here. She knows all the fields. We're prepared to talk to you. So this is what we have. How can we analyze this? And in principle, we can get permission from is that what you meant?
Slightly. Yeah, that's the first step. But okay. What I'm trying to say is that even if you give me all the data, without any knowledge of the field, the smartest computer scientist with the biggest computer cannot get anything useful out of it.
Well, I agree.
We need really a collaboration and ongoing collaboration. It's just not just a matter of pushing the data to us and tell us.
No, I never had that in mind. No. Yeah. I totally agree. I mean, absolutely. But that would be the idea. You see, we have some other questions, and you say, well, have you thought about looking at it this way? And then you probably have programs that are saying, you never thought of this association. Look what's coming up here. I'll give an example of computer science. Now, David Chiquetto, who's an experimentalist, and I discovered a place in the brain called the insula that if you damage it, you can die from a sudden arrhythmia of the heart, sudden death. Now, we did that experimentally. The observations began clinically. We created a model. We showed experimentally. There was a very smart guy in Boston called Koroshetz, and apparently he works with scientists like yourself, computer scientists, and of course he's using MRI. And what the computer is programmed to say is, give me any associations with tests that are done on these acute stroke patients. It turns out that troponin, which is something that the damaged heart would release into the blood, are elevated. The computer program that doesn't know anything about the brain localized the strongest association was with a lesion, guess where? Not only the insula, the right insula, which is what we showed experimentally. So again, we can say to you, these are hypotheses that we know about, can you test it? But you can also say, look, my computer tells me there's this funny association, an ingrown toenail with heart arrhythmias. Never thought of it. There may be a connection, maybe it's infection. So that's how I see it, but definitely there has to be a commitment. And, that's why we're here.
We're here not to throw data across the fence. We're not doing that anywhere. We're here to actually establish a transdisciplinary interaction. In other words, I expect a number of us are going to get deeply into mechanisms of brain function, the biochemistry, whatever it might be, learn from and through Vlad, but the other way around, he's going to learn a fair amount about concepts from ontologies to data mining or whatever it might be. So no, this is meant to be a deep exchange and the establishment of an intellectual unit of a group of people. So I understand your frustration. We've been through that many times, but we're forming more and more of these, and they're incredibly successful. Jeff Orchard in computer science is an example. He's become an expert in functional MRI and the issues of radiotherapy, as well as the stuff that he's doing on tracking motion of organs during radiotherapy. So, no, very good point, excellent point. So if you don't want to learn a lot about the brain, you don't want to work on the ideas, same thing, if you didn't want to learn from this, it wouldn't work. So we're interested in the deep exchange.
With the experimental work, I don't work in the laboratory, like I don't do experiments. But I spend enough time in the laboratory to know what's actually done and stayed overnight and see what they do. And now I don't get to the laboratory, but it took that intensity. And of course, I meet regularly with my colleague who does the experiments. And he's learning a lot from me, I learn a lot from him. And we can do more together because, he'll come up with something I never thought of. To me, it's, well, that's not important, what I would say to myself. But then he said, but it's important to me because, and vice versa. So, no, and we're serious. I mean, we are serious because, as you can see, I've been frustrated. In fact, I first advocated having a common standards in 1992, an article in Lancet. It took almost 50 years to bring it about. And it was, in fact, it was a big struggle. And now that it has happened, everybody said, well, why did you do it before? Well, I've been trying.
want to ask one more question, but anybody else have a question on me? All right, quick one. As I remember from the nun study, that one of the early things they detected with regard to the cognitive behaviors was that the nuns who eventually got Alzheimer's, as I recall, used simpler sentences.
That's correct. Goes back to what your colleague was saying, that a very powerful predictor of who's going to develop Alzheimer's disease is how well they did in the essays when they had to apply. Right. And I think there's things like density of meaning and sentence and things like that. And it looks like the higher your IQ, the more likely you are to preserve your brain. That has been shown. However, people have thought that it's just poor material in the brain. However, we have done a study based on the longitudinal observation in London, Ontario, where we saw the patients initially and then saw them, well, 72% of patients actually donated their brains, that we looked at people, the least educated, because there's this big thing, because people have multiple degrees, they say, well, I'll never get Alzheimer's disease. And they said, well, because you have better brains, what do you expect? Well, I hope it's right, but may not be. But anyway, we divided the people into those who had primary education, secondary education, and college and beyond. And it turns out that once they developed Alzheimer's disease, they all had, they all went the same way. The brain weights were the same. They had the same number of Alzheimer's lesions. The difference was the least educated had more vascular lesions. And we know that people in the lower socioeconomic groups have more heart disease. They have more strokes. They have more risk factors. So it may well be, I think the fact that the more highly educated you are, the less likely to develop both stroke and Alzheimer's disease, numerically. But the explanation may be in the risk factors and not some intrinsic building up of reserve.
One of the great strengths, as I talked with you, by the way, this is part of a very large interaction that's built around this Canada Foundation for Innovation program, which is going forward with Western, and together with Waterloo, the Institute, and with Windsor. So this was the meeting we were at a couple of weeks ago. So this is really within an environment of real stuff, funding and people and so on. And there were about, 60 or 70 people at that meeting, as I recall, all the scientists, if you want, in the region, with regard to medical scientists. The reason this is important, it seems to me, and we have an incredible psychology department here, which not only gives birth to psychologists, but to a lot of our people in applied health sciences, interestingly. And I'm wondering, psychologists have done a lot of work in the measurement of cognitive function. What's been done in looking at these different types of cognitive impairment and creating tests that test for the different signs of that at different levels? There must have been a fair amount done.
They haven't tested, but they begin with the assumption there's been a big fallacy. And the big fallacy says, okay, please define what patients you're studying. So they use some of these criteria. I'm studying an Alzheimer's patient. And then, of course, if they exclude the patients that have vascular disease, they won't find the differences. And so there have been hundreds of attempts of classifying it from that viewpoint. But I think the premise has been wrong.
I think one very big contribution potentially is looking at the cognitive function testing area and getting what I'll call correlates with knowledge and evidence, if you want, in terms of the medical causes, and then coming up with testing schemes. And then a second real strength here is a huge expertise in population research.
Oh, really?
Absolutely. Incredible group of people. It's an amazing thing. And, of course, Yaping will be interested in that. Not all of them are epidemiologists. They're in all kinds of different areas. Interestingly, a lot of them with psychology and cognitive science kind of background. So there really is a potential here for looking at these different issues on both the measurement basis and looking at some of the population issues. So that may be something that comes out of it. Now, others of you may have comments on those or any other comments about this topic or about the interaction. Any thoughts? If not, what we're doing now is we'll break to the 13-16. And Vlad expressed an interest in meeting with a number of people. I'll be there. I hope a number of you will be there as well, and having a discussion about, where might we find common areas of exchange between the University of Waterloo and the work that Vlad is doing. So, Vlad, thank you very much. Really appreciate it.